Okay, so now I'm here at the Department of Kinesiology at the Curry Gym with Maxana Weiss, who's the Administrative Coordinator for Let's Talk Science McGill. And she's going to show me some stuff on the DNA extraction from strawberries and cell dynamics. So thank you for taking the time to show this to me and for welcoming me here.
No problem. So what we have here is we just have a couple of pieces of strawberries that are already cut up in little bags. And what we basically do is, it's quite simple. We take this liquid, which is, it's a cell lysase, or something along those lines, where it breaks down the cell walls. And all it is really is, it's a detergent, it's salt, and I think there's some water as well. And what we're going to do is we just, we can both do it at the same time. Or
perfect, yeah.
We'll take this one, and I'm just going to open the bag. And you just put enough of this to basically kind of cover the strawberry, not like that much, so it's soaking in a little bit.
Okay.
There you go.
And so do you prepare this solution yourself?
We sort of have things split among different coordinators, so actually Jasmin's the one who prepares some of
about
this
this
stuff.
much, right?
Yeah. And then what we're going to do is you're going to close your bag and make sure it's...
Do I want to get all the air out of it?
It doesn't quite matter. And then we're just going to sort of squish it. And you can sort of see some of it breaking up from actually pushing it. We'll each sort of, one at a time, pour over a cheesecloth and just a regular plastic cup. Just take your strawberry goop. And what we care about at this point is going to be the liquid. Perfect. And then we sort of take a cheesecloth, get some extra liquid out. Because at this point the cells are already broken, and everything that's in them that we want, so the DNA, is going to be it's going to be floating in the liquid. And we can't see it right now because it's all mixed in with sort of the strawberry juice and our detergent solution. So what we're going to do now is we're going to transfer it over to our little test tube. We want to get all of that. And from here, we're going to add some just normal rubbing alcohol.
And Sue in Ottawa was telling me if you're using 90% or higher, then you don't need to cool it. Because I'm used to having it like on ice in the lab and stuff, but that's a good tip.
Yeah, so I don't know. We've always used the very high percentage, and it's always been good at room temperature. So you want to add some of this. It's not an exact amount or anything like that, but if we have like 10, I'll probably add up to like 15 or something.
Just to have two clearly different phases.
Right. So we kind of want a bit of a mix. And then what we do is, all you have to do is tap it. So you're just gonna, if you would like, you can just sort of like tap it around.
Okay.
And what you're looking for is you're looking for sort of white globs to form at the top, and that's actually the DNA. It'll separate out of the solution and form sort of a little bit of a white cloud.
Yeah, like looks like snot.
Yes. It's pretty gross looking.
Now, a question that often comes up, and I think it was with Isabella, like one of the coordinators I met before, we didn't have a good answer to it. How do you know that it's DNA? Or how can you prove to students that it's DNA? Or do anything useful?
Right.
Do I keep flicking it?
I mean, that's pretty good, yeah.
Okay.
Yeah. So, I mean, part of it is just, it's the understanding that there's something that was in that juice that we made that we couldn't see before that we can now see. By adding different liquids together, you can sort of get a different substance out of a strawberry that you couldn't see before. Because if you start with a regular strawberry, like, you don't usually see a glob of goo. So that's
thank
basically
you.
that one.
Yeah, perfect. Thank you.
No problem. And then for this one, this is just, we have, in a lot of ways, we have a younger audience, so we do a lot of community events, and sometimes we have people of different ages that come by, so we can talk to upper levels about cell dynamics and cell walls and the purpose of the cytoplasm and the purpose of mitochondria and things like that. And for them, they can actually say, okay, well, this pom-pom is one thing or another, or learn more about the processes. And for the younger kids, we either have them draw or color, or they just glue what they like, and we sort of just tell them that cells exist and there's different capacities that they are used in. And so this is just another way of visualizing the components of a cell. So obviously it's gigantic, but just the idea that you can make something that resembles something in science is what a lot of kids like, because then they can say like, oh, this is something that it's tangible.
Yeah, that's pretty cool.
Yeah. So that's pretty much what we got.
Okay, yeah, thank you.
No problem.
Interesting, but I can't really find any useful details. I just need to have a look at it.